Maybe it's super hot in here, that's why the door was open. Anyhow, very much welcome to this presentation. I'm going to talk about CSPs and DBaaS that we have built for OpenStack. And yeah, we have been doing it for a while, and I'll tell you, a little bit about the requirements and how we built it up, right? So I think it could be good if you're thinking about building your own DBaaS, or if you then would consider that, that's probably it could be a big undertaking, or bigger than you would think, right? How many here are like DBaaS, by the way? Are there any DBaaS in here, or DevOps, SREs? Yeah. DevOps, SRE, yeah. Anyone here, with Postgres experience, for example? Right? Yeah, great. MySQL? Yeah. Are you running like MySQL in production, or? MariaDB, yeah. That's very popular. Okay, so let's get started here. My name is Johan Andersson, and I have been, I am from a company called Severalnines. And let's start with a business problem, right? So we have, two use cases, or probably perhaps more. But if you're a cloud service provider, then you might have, faced quite a lot of heat from hyperscalers. Even though we're talking about, cloud sovereignty and so on right now, still, I think, the hyperscalers are still, eating our lunch, so to say, and if you are then, if you're a CSP, I would also say that DBaaS is one of those most critical services that we offer to a customer, because at the end of the day, most applications need to have a database, right? And most users do not want to take care of a database. That's just it. And then, if you're, just need to have a database in-house, a database services in-house. Well, then it's a thing that is costly to build up. It requires quite a lot of expertise. How is databases working? How are they functioning? How are the replication mechanisms working? Failover, backups, and so on. So with this in mind, we then created CSPs, and I must just say from the beginning that the customers we have, and all of them are like expecting Amazon RDS standard, right? So if it's not, similar to RDS, then they just won't migrate, right? Or put the workload into a DBaaS, right? So it must be quite similar. So that means we need to have a, simple to use UI. We need to be offering what developers want to have, just a single endpoint to the database. It must of course be secure. We must be able to handle upgrades, scalability. Another thing that is really important is parameter groups, so that you can basically create a set of configuration parameters that you can then use to instantiate, databases from, right? So that you can replicate a database setup, right? So they all look the same, right? To follow your company's standards or so. And then, of course, backup, restore, and point-in-time recovery is also, mega important. So we created a CSPs, and we are then decided from the beginning to run the control plane inside Kubernetes, and then the data plane is currently on VMs, right? We're supporting the most common open source databases. We have support for a number of different cloud infrastructures, AWS, Google Cloud, but of course, as we're here, OpenStack, right? We support multi-regions, availability zones, and this is a picture showing the overall architecture. So what you see here on the left side here is the control plane, right, that we run on the Kubernetes. It consists of a number of backend services. It has some metadata repositories we'll come back to later. And this control plane, that is something that you can take and install on your Kubernetes cluster, right? So you can take this and install it. You would just use, we are providing head charts for this. So what you would go in there and do is to go in and configure up in your head charts what kind of data plane you want to offer to your end users, right? Now we're talking about OpenStack here, so you would like to probably configure up OpenStack. So you would go into our values file, set up some OpenStack projects, some network Attendees, credentials, right, to connect to OpenStack, and so on, so on. And you would also define what kind of databases you want to offer. Okay? Maybe you don't want to offer, all of them. Maybe you just want to have Postgres. Fine, just configure it up with that. You can also configure then, what kind of instance types you want to offer. Flavors, small, medium, large. Or you can also configure, you can also configure different volume types if you'd like to. So if you have, high IOPS, volumes types that you want to offer, you can of course do that as well. So the workflow is pretty much as this then. That that we offer a set of ways of accessing the control plane. Right? So we have a web UI, we have a Terraform provider, and also a public API. So any way you choose, right, you can go into, for example, in the Terraform provider, and you would set that I want to have a data store of type Postgres, 2 nodes, on this instance type, and then you would do Terraform apply, and then there would be a job sent to the backend. The backend will then connect to the data plane and create the infrastructure, right? So you create the VMs, create the storage volumes, create the networks, and so on, right? Security groups, things like that. Everything that is needed. And when that is done, a second phase of the job begins. That is actually then, and I should say that during this phase when we're creating the VMs, we're also relying on, when the VMs are booting up, we're relying on Cloud Init to provision the node with software, right? So it's setting it up, the certificates and database software and so on, right? Make sure everything is mounted, that the volumes are encrypted with logs, things like this, right? That's happening during the cloud interface. And when that is done, then we have created the infrastructure. And after that, we are then running a job to actually create the database cluster on those VMs. So that means it's a Postgres. You have selected that you want to have 2 nodes. One node will be primary, one node will be replica, and we're then setting up streaming replication between, making sure that that works, and then we're also creating backup schedules, so that eventually then the entire node has been, or the entire data store has been set up, right? Yeah. On these data stores, we then have Fluent bit for log collection that we're forwarding to Aluki. I don't have it actually on the picture here, but we're forwarding the logs to Aluki then, right? And we're actually then showing the logs in the end user UI, right? So that you can look and feel, that your actual database is running. And then we're also relying on exporters. So the Postgres exporter, node exporter, and so on. installing the nodes, and then we're using Victoria metrics to scrape them. So that's how it looks like on the infrastructure side. And please interrupt me if you have any questions.
I have a question.
Yes, sure.
First, most of the people, they are trying to get off from VM to containerized system.
Yeah.
Like what you are suggesting is have a control plane for the containerized system and then orchestrate that VM. So why is that? Is container is not sufficient for the database workload?
Well, we have taken the VM approach here right now, and frankly, we do have support for or I should say, beta support for KubeVirt, which is like a VM container running inside Kubernetes. But we do not yet run provision the data stores as database operators. We just don't do that yet. It's on the roadmap, but we haven't got that far yet. That's just a simple.
Okay. The second question is regarding Microsoft SQL Server.
Mm-hmm.
So how exactly do you manage the licensing? Because sometimes customer will say bring your own license and stuff like that.
No, we don't accept that. We don't want to take in existing licenses. So for an SQL Server, you have to have an SPLA license together with Microsoft, and you would sort it out, right, together with Microsoft. I mean, if you are, well, for my part, for our part, we're not, enforcing any license checks whatsoever anyway. So maybe, it's fine for you to take in the existing license, but you're not going to be able to add any product keys or anything like this inside the product here, right?
It will be a Linux base for.
Yeah, it is Linux base. Yeah, exactly. So I should also say that currently we are creating the VMs using Ubuntu 22.04, right? So and that's the current. So all these data stores, all the databases, you say, are deployed then on Ubuntu 22.04. For easy access, because that's also one maybe important requirement, that you want to have a single endpoint to your database cluster. We are leveraging then external DNS for that. How many here have used external DNS before? Yeah. So I think it's great. This means that you can configure it up. So if you are using Route 53 or if you're using OpenStack Designate or whatever DNS you want, you can configure it as a part of external DNS. And then, we are creating the DNS record. So you would have a DNS record that will make sure that you connect to the primary replica of the data store. Yeah, so I think that was a little bit about that. We also then have a couple of metadata repositories. So for some various reasons, we have one for in MySQL and one for Post and one repository based on Postgres. The C6DB contains the metadata of the control plane runtime, and the CMonDB contains the runtime of the some metadata about the data plane runtime basically. So that's it. I should also say backups. You provide an S3 compatible storage. So this is your infrastructure. I mean, this is your infrastructure. This is your Kubernetes. This is your OpenStack. And you provide them some S3 compatible storage where then backups will be uploaded to.
Just a question.
Yeah.
Regarding PIDR, so how exactly that will be executed? So for point-in-time recovery.
Yeah. Well, maybe I can come back to that a little bit. But sure. It's normal with binary logs and things like that. So this is pretty much the summary of the stack. We do have a user repository, right? So you could use us, but I think in most cases, if you would take this, and then you already have your user somewhere, if it's in Keystone or Keycloak or whatever IDP that you might have, right? And we'll come back a little bit how this authentication, could be done then to the system as well. This is the kind of tech stack. Right? So on the control plane, well, we are leveraging Kubernetes quite a lot, so we are making sure that we are, running with multiple replicas and so on, right? We are constantly modernizing. So currently we are actually using Victoria Metrics in a single instance, but we are replacing that right now we have a project to replace that with Victoria Metrics cluster, right? So that you can grow quite large metrics collections. Then I think now we're going to talk a little bit more about the details here. What has actually been and what does it really look like? So we are, and maybe I should go back actually to this picture here. So here, if you see this dashed box here, around here, then that's your OpenStack, right? Then this is an OpenStack project that the control plane owns, okay? So we are deploying everything right now into one specific OpenStack project. So we are not deploying into any user projects. We don't have customer projects. We're deploying into our own projects, right? And in there, we're creating the VMs. And currently, we are requiring a floating IP there to be set on each VMs. Isolation is being done with security groups, right? So by default, a user that has been creating this, you're not going to be able to connect to the store until you have specified exactly what kind of cinders you would like to allow to connect, right? So it pretty much looks like this step, right? So the control plane will talk. Hello?
Yes. Are you finished?
No.
How long?
I think I have 10 minutes, right?
No.
You have 5 minutes.
16:35.
Was this only to 16:35?
Yeah, that's
Yeah, then we have a problem. I am really sorry that I wasn't realizing this was so short.
Didn't we start with a delay due to also the previous presentation being longer?
Yeah. But isn't the presentation 30 minutes?
Yeah,
Somehow you only got a 15-minute slot.
I only got a 15 minutes.
Yeah. I don't know why.
Okay. Can I just wrap this up then really fast? 1 minute. Okay?
Sure.
Yeah, right. So we do then also have multi-tenant support, and we are, leveraging JWT to that. So the thing here, and I think this is important, that you have your users will be logged in somehow, right, on your OpenStack or Horizon platform, so they are authenticated in your platform already, right? So what happens then is in your Horizon, you could literally create a button called DBaaS, right? And when you click on that DBaaS button, you will put together a JWT and set the project ID of the OpenStack project, for example, in that JWT. And then you will send a login request to the backend. And then we'll create a syntactic user with that project ID as kind of the user ID, right? So everyone that logs in, has this project ID will see the same data stores that have been deployed. Right? So that's how multi-tenant supported. We have different APIs as well. I'm really sorry that this was completely fucked up. I didn't know that. You're gonna get the slides, and please hit me up by email if you have any questions. Then the day 2 operations. That's when it starts to get funny. Okay. We are using one important principle: immutable infrastructure. So we're never trying to repair any nodes logging into or anything like that. If we have a failure, we're just going to create, add, and remove nodes. That's pretty much it. And update the DNS. You get it, right? You're smart guys. We are also hiring, right? So you have the more possibility here to listen more to me about this if you want.